Ladies and gentlemen, this is the last part of operations with scientific notation we're going to be talking about. Today is division. So I've got two examples right here. First one, x to the 7th power divided by x to the 5th power. Right here is just the long written out version of x times x times x 7 times, all divided by x times x times x 5 times. Just a long written version instead of the exponents. And what I also want to bring your attention to is once we're at this point right here, you can start simplifying. Everything on top and everything on bottom is being multiplied. So you've got factored form on top, factored form on bottom. Now you can start simplifying. And anything like x divided by x equals 1. So we've got a big old 1 right there. X divided by x is 1. Got a big old 1 right there. X divided by x. Basically, anything that's a pair, we are just going to simplify to 1 over 1, like I'm doing right here. And what are we left with? On the top, we've got x times 1 times 1 times 1 times 1 times 1 times x. So basically just x times x. On the bottom, all we have is, well, everything has a pair, so just 1 times 1 times 1 5 times, which is 1. So it might seem kind of confusing, but what are we left with on top? X times x. So we can simplify that down to x squared. If you remember laws of exponents, when you're dividing powers with the same base, the base is x, the base is x. All you have to do, subtract the exponents. So 7 minus 5 gives us our exponent of 2 right here. The next example, 8x cubed divided by 4x to the 5th power. So what I want to do is write this out in factored form again. This 8 can be broken down into its prime factorization of 2 times 2 times 2, which would give us 8. On the bottom, 4 can be broken down into its prime factorization of 2 times 2. And then, of course, we've got our x times x times x on top for our x cubed, and all of our x's on the bottom. Now notice that everything is being multiplied on the top, everything is being multiplied on the bottom. That gives us the ability to start reducing any common pairs. So we'll use our big old simplifying 1's up here. 2 divided by 2 gives us 1. We've got another 2 divided by 2 right there, which gives us 1. And then we've got 1, 2, 3 pairs of x's. So our first pair on this back side, our second pair, and our third pair right here. So what we're left with on top is a 2. On the bottom is an x times an x, simplified as x squared. So after we reduce some of those common pairs, 2 divided by 2 is 1, 2 divided by 2 is 1, x divided by x is 1, x divided by x is 1, x divided by x is 1. Anything times 1 is itself, so all we have on top is 2. All we have on bottom is our x squared. Now you'll notice the 2 comes from 8 divided by 4 is 2. So the coefficients, you can divide them. That number is up top. These exponents, if you remember back to the law of exponents, dividing powers with the same base, yes, we subtract those exponents. So 3 minus 5 gives us a negative 2. Okay, so if that's negative 2, how come this one's positive? Well, turns out that these two things right here are the same. Negative exponents. 3 minus 5 is just negative 2. Well, up on top of negative 2, That's not simplified. The simplified form is on the bottom, so that's why you have the x squared down here. Something to keep in mind, if you have negative exponents and you want them to be positive, you have to flip them over to the other side of the division sign and make the exponent positive. So this negative 2, x to the negative 2 power, well, we flipped it to the bottom, and now it's positive. It's easy to see right here with this long work, but you should know that all of these right here are equivalent. 2 over x squared is the same thing as 2 times x to the negative 2nd power. We will now move into scientific notation, how this is going to work. Very similar. When numbers in scientific notation are divided, only the coefficient is divided. So the coefficient is divided, the exponents are subtracted. So scientific notation, the coefficients, the numbers in front of these powers, they're divided, and then the exponents are subtracted. So 9.6 divided by 1.6 in this example gives us our new coefficient of 6. We've got these powers we're going to subtract. 7 minus 4 gives us our new power of 3. So our simplified answer is 6 times 10 to the 3rd power. You want to double check. Okay, there's only one number on the left side of that decimal point. Yes, it's in scientific notation form. 2 examples I want to go over together. Right, so the first part, scientific notation, we got numbers being divided. You want to divide the coefficients. So 4.8 divided by 1.6. And then you're multiplying that by 10 times, let's subtract those exponents, 8 minus 3. Make that a little bit bigger. When we simplify that, our new coefficient, 4.8 divided by 1.6 is 3, or 3.0, times 10 to the 8 minus 3 gives us the 5th power. So our answer, 3.0 times 10 to the 5th power. What we did, we divided the coefficients and we subtracted the exponents. This next one, you might want to try on your own, see what you get, and then pause this video while you're doing that. When you start it back up, we'll go over it together. Alright, so the rule, divide those coefficients, 3.0 divided by 1.2, and then you want to subtract the exponents. So 3 minus 7. Alright, so what do we get when we do 3 divided by 1.2? Our new coefficient is 2.5. Multiply that by 10 to the 3 minus 7 gives you negative 4. So that is key. Might be kind of difficult to see here, but make sure you have a negative sign in front of the 4. All that means is that this scientific notation, this number right here, indicates a really small number. Anything with a negative exponent is a really small decimal used to describe really small things. Double check, we only have one number to the left-hand side of that decimal point, so yes, we are in scientific notation form. You should have a few practice problems on the back of your guided notes. Go go ahead and do those. If you want any extra practice ones, just let me know. But hopefully you feel pretty comfortable with dividing numbers that are in scientific notation. Peace out.